The map of this video is one featuring many stops at mini lectures about the many wonderful map-based operators available with RxJS. We start the journey by importing map from RxJS operators. Next, create a transform data observable property. We'll use this to distinguish original data, namely our mock data here, from data that we transform using various RxJS operators. To the property we call pipe on the data property and pass the map operator as an argument. Pipe is a method available on all observables. It takes an infinite number of operators, in other words functions, which it executes in order. The term pipe is fitting because we're putting data in at one end and getting data, usually of a different form, from the other end. All operators are passed to current data in the state corresponding to previous operators. Given that map is our first operator here, the v argument, short for value, is the original data as we wrote it. So we'll just map directly to that by returning it. To test, we create a subscription just like for the original data. We'll also wrap the console log argument in curly brackets to get more readable statements. So now when we fire it up, we see the original data and transform data objects. Now let's actually transform some data. For better intelligence, we could write a separate interface for the mock data like so, but a neat little treat you can do is cast in the current data as a constant and then creating a type assigned to type of mock data. This tells TypeScript that the original data is read-only, enabling us to be more sure about its values. Now we can cast the original data observable as observable of type mock data. Now within the map operator we have intelligence on the past value. Imagine working blind on an extremely large complex dataset. This is the reason TypeScript is deservedly championed. For now let's just map to the first item of the array. And there it is. You can play around and do what you want here. Change the mock data from an array to just the object. Now we can map to specific values from the object. There's a few ways you can write this code. It really depends on preference. We could use classic block function syntax with return statements. Most of the time, however, lean arrow syntax code is the way to go. Here we're simply mapping to a new object containing just the name and UID. And there's our transform data. We could also use deconstruction here. In the map argument, we grab only the name and UID properties from the incoming object by wrapping the argument in curly brackets, which allows us to simply map to a new object using this linear property notation. And as you can see, we get exactly the same result here. This of course wouldn't work if you wanted the name or UID under a different property name. It also wouldn't work if for some reason the name or UID property wasn't available in the object passed to the map operator. It would throw an error, which we'll get to later. We can also do a similar transformation using the pluck operator. Say for example we only wanted the name value. We'd pass the key of the property we want as a string, and that would be the result. But pluck is a rather problematic operator to deal with, especially with file-based like observables. It's good only for situations in which the data is always of the same structure and the properties to be accessed aren't very deep. In other words, stick to the map operator. Talking of errors, let's throw a spanner in the works by making the observable spit out a null value instead of our data. When first learning RxJS, get used to these errors. It's telling us here that the name value doesn't exist on the value passed to the map operator. What we do then is check first whether the value is truthy before trying to use it. If it exists, we do as normal, else we return null. When working with asynchronous data, such as user data coming from a database, it's guaranteed that the data will not always be available, either because of a connection problem, something with the device, fragile code, or something else. For instance, if the user logs out but is somehow still viewing a component that live streams their data, then what will happen when that data stream is cut off? Well, in most cases, the value will become falsy, meaning operators like map will throw an error if checks and fallbacks aren't in place. So we've looked at map, but rarely is the data as simple as our mock data here. Go ahead and add some more user data objects to the mock data array, then comment out or delete the previous map code. Say for instance we want only the data of users whose age is 51. The common mistake JS developers make here is to turn to the RxJS filter operator. We'll get to that later. For now we simply call the native filter method on the array and look for values where the age equals 51. And that's it. Be sure to check the observable from null back to the mock data before testing things out. As you'd expect, Jane and Anne's data is logged. Now we're going to look at the mapTo operator. If you wanted, for example, to log a statement to the console every time some data is emitted, the mapTo operator would come in handy. Here we map to a string doing just that, and in the console, our revealing string is logged. Finally, we move on to an extremely useful operator called switchMap. Odds are you'll be relying heavily on this in your Ionic app. Its purpose is to enable mapping from one observable to another. The most obvious use case is a database query for the user's data. Before we query the database, we need to know who the user is, hence they first must log in. Typically, and mainly for safety reasons, these are two separate features of an application. We could use switchMap to map to an observable that watches the user's authentication status. When it emits a truthy value, and therefore some useful information about the user, such as the UID, we can use that information to query the database and return some data. Sequential code is a critical part of UI work, and pretty much all programming. But JavaScript is a language that runs in loops, meaning it actually never stops running. If there is code, it gets run. This is where things like observables, promises, and RxJS operators like switchMap really shine. So here we create an arbitrary observable using interval from RxJS. It emits a value every 5 seconds. In the pub is called switchMap, and for now simply map directly to the interval observable. In the browser we get the data logged every 5 seconds. Now if for some reason this data wasn't available, or falsy, we'd again get an error. Just like with map, we address this with a conditional statement using the ternary operator expression. Unlike map however, switchMap doesn't automatically wrap its result in an observable, so we return null in an observable form using of from RxJS. We'll be using switchMap a lot throughout this course, in addition to many other operators, so don't worry too much about not fully understanding things yet. They'll make more sense later on.